All right, now before we get to strike out our patterns on the fabric, what I would like to do is to go a couple of steps back and talk about some of the fundamentals that are related to fabric and patterns, because if we are laying patterns on some fabric and we're cutting them out, we might as well know a couple of very, very basic things about them so that we understand why things are the way they are. Now, to make a jacket, we obviously must have a pattern, and to have a pattern, we must understand pattern drafting. To understand pattern drafting, we must know about construction lines. And to know about construction lines means looking at fabric. And when we look at fabric, what we're going to see is something called a weave. Now, what's a weave? Very simple. If we take a bunch of vertical lines, which are basically vertical threads, which we call yarns, and we run some horizontal yarns through them, what we're going to get is this square grid, which is basically a weave, a plain basic weave. Now, this grid has a vertical axis and a horizontal axis. The vertical axis is what we call the warp. That's the longest yarn on the fabric, which is parallel to the selvage. So if you have 20 meters of fabric, that 20-meter yarn is the warp. It's also known as the length grain. Well, think about it, it's the longest yarn, so a length grain. Then we have horizontal lines, or the horizontal axis, which we also call the weft of the fabric. It's the yarn that's woven into the warp. And we also call the weft the cross grain because it runs across the length grain. Both of these grains are falling in the same category of the straight grain. So if someone says cut it along the straight grain, maybe sometimes you have to ask, which one do you mean, the warp or the weft? Because they will react differently on the majority of fabrics. So if we introduce some colored yarns on our warp, which is the length grain, what we would get is a striped fabric. This is a red striped fabric now. And if we introduce some colored yarns along the horizontal weave, which is the weft, what we're going to have is a check. Very basic and simple. Now this weave, once woven, this fabric, once woven, behaves in a certain way. So when we interact with it, or we drape it over an object, or it just hands and gravity pulls on it, it behaves and reacts in a certain way. But it also has an alter ego which is invisible in the first place. That alter ego is what we can call the bias. What's the bias? Very simple. The bias is an invisible line that runs diagonally on a 45-degree angle across the warp and the weft, or aka the straight grain. And this bias behaves very differently than the warp and the weft. So we could say, as a summary, once we weave fabric, we have three directions to look at and to work with. We have the warp, which is the vertical direction. We have the weft, which is the horizontal direction. And we have the bias, which is the diagonal direction. Now, what's this whole behaving thing about? Suppose we take this piece of fabric, and I've kept the selvage here so that you know that the selvage is representative of the warp, the longest grain of the fabric. And what runs across it is the weft. If I would pull the yarns, or the fabric, which is just a bunch of yarns together, along the warp, there is a lot of resistance and very little flexibility. However, if I would pull it along the weft, it's still strong, it's still on the straight grain. However, it's a bit more flexible, it has a bit more give. But if I would pull it diagonally from these two corners, what I would get is a lot of flexibility and a lot of stretch. Now, why does this happen? First of all, let's start with the bias. If we, let's say, take a piece of thread, which is basically one of the yarns of the fabric, and we pull it apart by holding both ends of the same yarn, when we pull it apart, we are putting tension along the length of this thread. This tension is basically the result of resistance to break. Since this is not an elastic band, this doesn't stretch a lot. So if you have tens of these and you pull across them, like we do on the fabric, there's going to be either a lot of resistance or some resistance, but it definitely isn't going to be stretchy, although it may be a bit flexible. But when it comes to the bias, we are not pulling or holding the yarns, the same yarn, from its opposing ends. What we're doing in essence is as if we are somehow magically pulling this yarn from the middle into opposite directions, so upwards and downwards. And this is what is going to happen when we do that, because we're not holding it from the ends. We're holding it from, well, these two ends, which are basically 1/3 of this yarn now. The same thing happens on the fabric. So if I would flip this over, what you would have is this green line that runs along the fabric, which is just running along the straight kind of like grain. If I just make it a bit more visible for you, we have this green line, and that represents one yarn, one thread. Now, if I hold the fabric from the red point and the blue point, what I'm doing is I'm holding one end of one yarn, which runs both horizontally and vertically, and the other end, the opposite end of another yarn, which also runs vertically and horizontally, but doesn't connect to the yarn that I'm holding in the red corner. So I'm not really holding the both ends of the same yarn, which would be this. I'm holding one end of one yarn and the opposite end of another yarn, and I'm pulling them apart. Now watch what happens. When I pull this apart, you can see that a distortion happens on the green line. This green line is then pulled apart from kind of like the middle points, upwards and downwards, and it resembles this thread that I've just shown you. And therefore it allows the most flexibility because there is no resistance or tension directly on the same yarns. So that's basically the bias. Now that we know about the bias, we can get rid of this and get rid of this and just take a look at this drawing here. There are two ways we can wrap fabric around a body. One of them is so that the straight grain runs along the length and the width of the body. You can see this grid running from the top to the bottom, from the left to the right, and vice versa. Or we can wrap it around the body so that the bias, so this 45-degree angle, runs along the length and the width of the body. In this case, it would mean that our straight grain is not running from the top to the bottom, but is running diagonally from one top corner to the one bottom corner. Now, which one is right and which one is wrong? Both of them are right. It just depends what the design is and what the purpose is of that wrapping around the body, so the garment. Well, let's look at the left drawing. If you have the strongest yarn, which is your warp, running from the top of the body to the bottom, you have it basically on your center back, on your sides, and your center front, and every area in between them. And you have your weft going around the circumference of your body, like your chest, your waist, your hips. And that allows a bit more flexibility, but it still is a strong yarn. Basically, the grid will hang at its most stable points from your neck to the bottom. If you bend forwards like the red figure, what's going to happen is the strongest yarn, which doesn't like to stretch and isn't flexible, is going to move along with you, but it's not going to stretch. Therefore, if you bend forwards like 100 times and then go back to your original position, by the time you move back to your original position, your center back or your center front, whichever, probably center back because that is stretched out the most when you're bending forwards, is not going to have excess fabric running along it because it hasn't been stretching out. However, on the other hand, if you have the bias running along your center back from top to bottom and across, every time you bend forwards, since this is very flexible, it's going to stretch more and more and more. Now do this 100 times and by the time you're done, you're going to have the back stretched out so much that even in the neutral position, it's going to have excess length just sitting there. Now, this doesn't mean it's wrong. It just means that if this was not intentional, then you have made a mistake in your judgment in the way you made the pattern and constructed the garment. So what's the difference, and when do we use one and when do we use the other? Very simple. Every basic standard garment is more or less cut so that, well, cut on the straight grain. This means that the panels are laid on the fabric so that the longest part, let's say from the neck to the hips, runs along the selvage, which is the warp, and the width of the panel, which is, let's say, our chest size, the width of our pattern, runs along the weft. On the other hand, when you're laying out your panels on the fabric and you want to cut them out on the bias, you're not laying them out in like a nice rectangular square grid. You have to put them diagonally on your square grid, and that means that you're going to have eventually points that are going to end up as waste, because, you know, if you put this on top of here, you may not be able to use this area, so you've been wasting a lot of fabric. So there's always some waste in cutting things out on the bias. However, there are a lot of garments made on the bias. They just require a different kind of construction and a different way of approaching the pattern, because if you know that your fabric is going to stretch out, maybe you want to make the pattern smaller or reinforce it in some way or some area that you don't want to be stretched. Now, because industrial revolution has forced us to be efficient and economical, the majority of garments and the majority of pattern cutting systems are developed around the straight grain. And this leads us to the next part, which is the pattern, because this horizontal and vertical axis, which is our grid, is reflected perfectly into our modern cutting systems.